So again, a pleasure to be with you and to kick off the channel Lighting track. My name is Visser. I'm, as you said, the co-founder of Luximprint, and I'm in the honored position of leading the company since the start of this year. Basically, anything that touches lighting, optics, 3D printing is my special interest. So if there's anything you would like to know, please reach out to us. With your permission, I'll take you on a journey today regarding the optical 3D printing of custom optics, whereby we utilize our own developed proprietary process named print optical technology. Rather than focusing on a very specific application, I'd like to take a little bit deeper dive into the technology itself, finally ending up with product groups so you can see how technology itself can be transferred to certain products and finally some application cases if we have the time for it. A few words about the company. Some of you may know us as the spin-out company of Luximprint, the company that invented 3D printed optics back in 2009, so close to 50 years ago. That company was acquired by Meta not so long ago. Before that moment we already did spin out this Luximprint, basically continuing the multi-market prototyping services for mainly lighting related industries. Whereby we own the process, innovate the process to this day, not sell the printers but the service, and whereby we focus on getting the parts directly from the CAD file to the optical part itself. Our headquarters are based in Zeeland, the Netherlands, which is 2 hours down south from here. We have representations around the globe. Now what is it that we want to achieve? Apart from developing our own process, we want to have our users benefit from it. As we all together here as technology inventors, at least people with an affiliation to it, we think it's important to give people something in hands, see it as a toolbox, by developing print optical capabilities that can be used to drive your innovation forward. By, for example, reducing the time to market, and thanks to the fact we have no tooling involved, there's a lot of benefits attached to that, such as no need for order quantities, no stock levels, all those kind of things together. But above all, we want to explore people the benefits of our process for their own processes and materials. So that means new materials can be developed, new products can be developed, basically empowering new product development. We do so in a fast way. We try to get our parts out in days rather than weeks. And what we really want to encourage is to trial and error. So the process is flexible, there's no study, no tooling involved. So we can go with one part in a job, it can be also multiple variations. After the testing and application, you can run a round of variations. So flexibility is really there, and as such in a cost-effective way. That means for the parsing process, but also the fact that we're saving significantly on tooling and inventory, for example. If you take a deep dive into the technology itself, some of you may know already a little bit about the basics, but in the very early stages we developed the technology with its roots in UV inkjet printing. So we have the capability of putting a droplet on the spot, controlling the droplet behavior, the flow of the material, the curing of the material. So as the image you can see, for example, the UV curing lights are attached to the print heads, which are moving back and forth. So in a deposit, multiple droplets are put down, or you speak thousands of droplets at the same time, before they get cured by UV light. And we have a lot of parameters to play with, such as the strength of the light, the speed, the droplet size, and all these kind of things. The image may indicate we are stacking layers, which is not exactly the case. It's more that we have print head movements, whereby the print heads move back and forth. And after the movement, the material is cured. So we can basically stack multiple builds upon each other, ending up with a perfectly smooth surface and a built object that's completely clear at the inside. So all the surfaces we get out of the printer are, contrary to most 3D printing processes, smooth. If you want, you can also have water droplets. So rather than having smooth surfaces, you can make them a little diffuse, as you will see in a minute. And both capabilities are coming straight from the process without the need for post-processing. So you don't have to polish them or grind them. The parts are ready for use. We're always very open about the possibilities and limitations. There are some, because we are working with one single material. There's no support material, for example. We have limited capabilities in building overhangs, for example, or undercuts. But on the contrary, we have the capability for precision and making large format optics. So we can really make close to a square meter of optics. You can see the later in the booth if you want. Yeah, and the golden design rule, I would say, is basically we are good with droplets. As much as I would love to change the shape sometimes from round to square to have better accuracies, the droplet remains rounded. So it's all about precision, about curing, and so on. What is interesting and maybe a little bit uncommon in the industry is that in our process we can also load external materials. That can be the substrate materials. As you may have seen in the other picture, we are starting to build our structures from the plane. This can be a substrate of PMMA, glass, PET, and even non-translucent materials. But you can take existing laser developments as well and rework them. So say you have an optical development that is close to perfection but not good enough, we can take it in the process, put it in the vacuum and overprint it by frosted finish, by adding a texture for example onto it. It can be sheet materials again, but it can also be existing lenses or lens arrays. And we can print on two sides of the plane, so you can have structure attached to two sides of the given optical solution. Like I mentioned before, we can go pretty large. The capability we have still inherit from UV printing, which is typically developed for large format items. So we can go up to close to a square meter for a given object. It might be one single item. It can be also plenty of lens arrays as we'll later see in the showcase area. We have two materials basically we are working with. The first material, trying to get to optic, is an optical polymer resin that is applied to the sheet. The second one is an evolution of that one, I would say, by we basically work with an enhanced material in terms of lifespan, whereas the first material is perfect for, I would say, temporary prototyping and rapid validations. The second material is much more mature and allows also end applications. It has the strength basically of PC and the optical performance of the MMA, so it's a very strong and durable material. I mentioned before that we can do frostings as well in the process, so going from smooth we can take it more to diffuse and matte level with different purposes, but we can also make combinations, so if you want to have in one process optical surfaces and smoothness combined, that's very easy doable for us. There are some examples of printed frosted finishes, whereby we try to mimic typical VLBI roughnesses. So the mold roughness you are using sometimes in your tooling, replicate on the end products is something you see here. Of course, this is not it. We can also develop roughnesses in between, ranging from very light ones to very heavy ones, from finishes to textures, I would say. So how does it relate to the products? Like I mentioned before, we make custom items, so there are no stock items in our company. If we have any stock, it's basically digital. But we do have certain product groups whereby we have more or less products arising from, which are, as you can see on the screen, optical parts, reflective parts, where we basically take benefit of the smoothness achieved by the printer and then add a coating to it. Might be aluminium reflective, which is the most common one. It can be copper, it can be gold. There's some other things we can use. Color capabilities are still there, so we can generate more, I would say, art-like branding items. The textures are very interesting, also large format textures, and contra molds, which are basically doing the negative rather than the positive. Let's zoom in a little bit. Here we have the optical performing parts. Like I mentioned before, it's really related to droplets, which you can see here in the image very clearly. Frosted finishes, different gratings. As for the reflective items, we can work with either printed structures that have them coated, or we can also use non-translucent substrates, let's say reflective substrates, and have our structure applied over it. Thereby you see no clarity anymore, but reflections take care of the rest. When it comes to textures, we've created a great variety over time of different items. These are most used in validation of tooling. Imagine before you go to the embossing tooling in large format, huge investment, you want to have certainty about the thing you have developed before doing the real investment. So what we try to do is to mimic all these structures, provide our users with a marking sample, demo mock-up, and so on, and to take the next step from there. Another interesting field is optographics, as we named it. As the name assumes, it's optics and graphics combined, which can be one-sided optical masking, basically. So we use black and white tints or resins to block off the light and just have the light trespass through the openings that we want to. Or we can have it more colorful in the way we like it. It's a little bit off micro optics, I understand, but it's an interesting topic to show, which might find its way more in the artistic world. So you get line designers, like artists, or jump into it, because they're now offered capabilities that were never available before. You can easily hand in your optical design or graphic design. You can turn it into an optical functional shiny part. If we bring it all together, it's basically optical design, software, powering, digital fabrication. If you bring these two together, you can see compared to the traditional timelines, there's a significant advantage of winning time. So we gain time by compressing the steps in the process. The fact we don't have tooling involved really shortens the process itself. I won't speak too much on the optics design. We do have in-house design facilities, but also a group of designers around us operating globally that are really trained and educated to design for our process. And then you see next like tools, they have also their own technology, their own softwares that are optimized for our process. And again, if you bring it together, that's pretty powerful. I think some other presenter mentioned it before, it's all about customization. And this technology is special, is something that is greatly allowing for it. At the one hand, we have the speed and flexibility of the process of the making. At the other hand, we have the imagination and the tools of the designer. If you bring these together, that's pretty powerful. Now, before we go, we have some quick showcases, use cases that we did over time that demonstrate quite well how this technology can be used. Here are some pillar lenses used in automotive applications. Whereby all the lenses may be the same or different in curvature. Speaking large format, we step a little bit outside the lighting, but it's inverse lighting, I would say. Large format solar applications, and then before creating the large formats, we could have these companies trial and error with small snaps, I would say, from the bigger portion. They take out finally the most performing, the best performing optical texture, and they go from there. As you can see, we had a total of 32 different textures developed. They may look all the same, but they're all different, by the way. At the end, one specific texture was taken out and the whole plate was generated. Digital TV, 3D TV, whereby we utilize micro-optics and or micro-like items, enabling finally the bird or other objects to fly out of the screen. You can go online and view the movie of this particular showcase. It's really interesting to see. Very recently, we had an interesting cooperation with some designers on the Dutch Design Week here in Eindhoven, around the corner. They basically re-engineered LED panels. So LED panels that are used, for example, as the example here, they turned it into a functional lighting module, whereby basically any of the pixels is controllable. So what we did is we created a plate for them. It was a very tiny setup. That's what we like the most, because they help these people now become their ideas reality by offering a very low entry solution for this market. But the plate you see is dimensions 50 centimeters square, whereby over 60,000 lenses are applied, roughly segmented in 3 different segments, but basically any of the lenses could be different. So imagine all the lenses need to be having a different function. That is possible from a design and a making perspective. We did this in a matter of 6-7 days, I think, in the end, from the whole development of the optic itself to the final application. Here's another close-up. You can see the difference in the dots, for example, on the screen. I've only 50 minutes, so I think we're getting close to that. So let me try to wrap up with a few thoughts that you can take home. So basically this technology has been developed to enable our users having custom optics prototyped in a fast, in a flexible and cost-effective way. So before you go to tooling validation or you want to develop validate your design, this is a very interesting way to go. Especially because we have no tooling involved. We go directly from the CAD file you provide, print it to a print file, and go from there. As said, I didn't go too deep into that, but there are different methods we are using in optical design as well. We'll have another speaker in enthusiasm from here. They do crazy things also with optics design, so we'll hear from them as well. And we believe that especially these combinations are extremely powerful in making new optics come to life. But we have full design freedom. It's partly often part of the process in the making and the design, but it's also the imagination of the design itself. You see some living textures, and for the printing process itself, it doesn't matter whether the texture is super complicated or very easy to process, you can do it pretty fast. And yeah, in the end, it basically asks for a mindset change. We're very used to think in the limitation of tooling and the current methodologies, and this is a little bit more free. It's not unlimited, of course not, there are limitations, but it's a different playing field, I would say. Having that said, thank you very much for your attention. You're most welcome to visit us at the booth if you want. Here for the next day. I hope my voice will keep up with that. Thank you very much for your attention, and yeah, enjoy it.